Hope you're not nervous. Okay. 6-4. Today's Wednesday. Test Friday. Ready to go? Big smiles. Take the challenge. All right. So 6-4 is just a different way of asking questions that involve inverse. So I will say that the way these questions are organized, restrictions are in action, but the first set of examples, and I didn't make great notes, all I did is pick different examples that's not in your homework. Homework's in the calendar. I didn't put a page number. You find it. It's 6-4. She just kicked me. All right? So apparently she doesn't like these notes already. Okay, well, I don't know. We can't verify that for sure. Okay, so here's the first example. Look at the directions. Solve each equation for x. That means I have to get x by itself. Does anyone know how I might do that? How I'd get rid of this sign? Inverse sign. Both sides. Circle your answer. I'll stop to let that sink in your head and see what just happened there. Ah! I don't know what I'm doing. I'm out of practice. Where's the thing? Can I inverse tan both sides right now? What do you think I have to do first? Divide by 3. Now, how do I free 2x? What do I do to both sides to free 2x? Inverse tan both sides. But wait, what is that free? 2x. What do I have to solve for? So instead of divided by 2, what would I prefer? Multiply by a half. And then you really got to understand that you do not, I don't like that, I'm being a little bit lazy, but I guess I will do that. That 1/2 does not get incorporated with the angle measure. Just 1/2 times the inverse tan of y over 3. Stop! Next. Can I inverse secant both sides? No, what do you have to do first? Subtract the root 2. Are you bored? You feel tricked? Oh, something's being hidden for sure. What do I have to do next? Can I inverse secant both sides? Divide by 3. Probably could have wrote that in 2 steps. Or, I'm sorry, in 1 step. And I could write it like that because I know what's going to happen next. Now what should I do? Now, some people do screw this up. They try to divide by 2. No, that's stuck in the angle position. So what you need to do is inverse secant both sides. I'm not writing that. We should know that. So now what we have is inverse secant of this expression. This is all you do, and this is how you write it. Then what do I do? Multiply by a half. That's your answer. I'll erase that 2 times 1/2 because I'm short, doing it real quick. The next directions ramp it up a little bit. What's the matter? Huh? I can't hear what he's saying. All right, here we go. So now, this one doesn't say solve for x or y. This one says solve. And what does this say right here, Chiefs? What does it say right there? Son of a, yeah, great timing. What does this say right here? What does that imply? What does that, no. What does that imply? No calculator. And what did you say, ma'am, possibly? Restrictions depending on how this all shakes out, what the order of things are. All right. So what do I got to do first? What was that? All right, what do I got to do first? What do I have to do first? You got to divide by 2. And I think what's kind of going on here, you got to know the order of things. This 2 times is outside here. I can't multiply both sides by 3. That's stuck in the angle. I got to free that first. Freedom. Arc cosine, I can't write, of all that stuff. Yeah, I'll write it all. Jeez. Someone will say something. Then what do I do? You cosine both sides. Does this have anything to do with restrictions? I mean, no, because there's an answer for cosine of pi, and what is it, everybody? What is the cosine of pi? -1. And then guess what? You have a grade school equation now. Multiply by 3. And then what? So multiply by 3. This is negative 3. And then add pi. Y equals negative 3 plus pi. Zippity-doo-dah. Okay. Now this one's a little different, but all it is a question you've already done, worded in a different way. So what I'll do is I'll turn it into that question that you've already done. See, you don't have a calculator, so you can't inverse tan 4/3. This is not a ratio, you know, so it's not like pi over 3, pi, whatever. Restrictions are in action, but it's a positive ratio. So what quadrant are we talking about? No, what quadrant are we talking about? What always wins when the ratios are positive? 1. Well, you're looking at me, but see the 1 and 4, and then I don't care about 4. This is quadrant 1. Good morning. All right, now what do I do about this? Oh, this is actually kind of silly, and it should be worse. So let me go through it all, pretending like I should change this. You know what? Forget about it. I am going to change it to inverse cosine, because that's too easy. Because what's cotan of inverse tan? What's going to happen to those two? Never mind. I'm screwing the whole thing up. I could leave it. Boy, good thing that's on the thing. Sorry. A little out of practice. Okay, so let's move on. Let's pretend none of that happened. No, it is kind of stupid. Let's make it cosine. Oh, my God. Is he scatterbrained? How do you survive in this class? Oh, I hate him. I don't. Oh, there we go. Let's get all the comments in. Okay. Yeah, because cotan and tan, it's 3/4, right? Cotan's the flip of tan, right? That's too easy. Okay, so what you do is you cosine both sides, and it's cosine of inverse tan of 4/3. That's why I had to do this, because the other way it's way too easy. You have to remember how I constructed this. When you inverse tan a ratio, what do you get as an answer? What do you get as an answer? An angle. And then you're going to turn around and cosine that angle, right? And then your final answer is going to be a what? So what you need is a triangle. And it is in quadrant 1. I won't draw. And what do you know about that that angle? Okay, it is a 4, a 3, and then what's the other side? And it just, if it happened to be a radical, then you'd use the Pythagorean theorem and find out what it is. This is theta. So what's the cosine of theta? What's the answer? 3/5. The answer is 3/5. So through that construction, you should understand that. So all it is a different way of wording a question you've already done. Heck, you just got tested on something similar to this. All right, that last one, number 6. All right? Is everyone okay so far? Oh, celery. All right. Now, Houston, we have anyone? We do and we don't. Okay. Which one looks like the toughest one? Really? The right one has 2 x's, and one has a 2x in it. The left one, I'm shocked you said that, because root 3 over inverse tan of root 3 over 1. What's the answer? Okay, but let's put it in radians because that's in radians. So now you've turned this into inverse sine of x plus the inverse tan of root 3 over 1. How you do this fast, you people that are not getting this done, y over x is what inverse tan is. What is always opposite the reference angle? Y. Hammer that down at least. And then you know what's opposite root 3. What angle is that? 60. So it's pi over 3. Now what do? Subtract pi over 3. Now what do? Sine both sides. Now what do? It's the sine of 60. Square root of 3 over 2 is the answer. Okay, now take a deep breath. I'll pause it for a second. Yep. Dun, dun, dun. No? No, I don't think so. It's the only one I've seen it in. All right, let's move on. We got problems here. Okay, here's what... Okay, so I looked at this. I'm like, oof. Okay, you have 2 choices. You could subtract this and then inverse sine. Or you could subtract this and then inverse sine. Now do both. So let me subtract this, and this one's the worst of the two. So let me subtract this from both sides. You get pi over 2 minus arc sine, and it's because of this 2x. That is an issue, I think. At least I can't, think about it. Then arc sine of x equals this. Then I'm going to inverse sine both sides. I'm sorry, sine both sides to get rid of the inverse sine. Right? So subtract and then sine both sides, and then this is what I would get. Or I do the opposite. Subtract this. That gets me pi over 2 minus, and this is how I kind of compartmentalized it in my brain. And then I sine both sides, and then I would have 2x free, right? Now, why is the second one easier? If I just get an answer for this, what do I have to do with this answer when I'm done? Multiply by a half or divide by 2. This one, how do I arc sine 2x? 2x is an angle measure, a double angle. Yeah, I don't know. I didn't even want to think about it. I know this is the easier way, the bottom one. But it's not necessarily easy because this implies there's a triangle involved that I don't know much about. So this is what you're going to have to do. First things first. Hold on. You're killing me, Smalls. When you arc sine x, what do you get? If you could do this, you get a what as an answer? Starts with an A and ends with gul. An angle. Let's call that angle U. Me? U. Okay, so let's pretend it's U instead of, I usually put theta. Fine, we'll put theta there. Okay, so then what we're going to do is set this up that it is 2x equals this, by the way. Sine pi over 2. And now this one works a little bit easier than 39 does, I assure you. What time is it? Okay. Cosine theta, right? Right? Minus or plus. Minus. I don't know. I switch it around. Cosine of the angle pi over 2, and then sine of theta. Why this is a little bit easier than 39 is, but I'm still going to keep going with it. Does anyone know what the cosine of pi over 2 is? No, it's not. 0 times this. Taken care of. Now, what I'll tell you, because I'm running out of time, is there is a quadrant issue. Remember with restrictions and all that stuff? Where does x reside, or where does theta reside? It resides in quadrant 1. Okay, that's all I'm going to have you worry about. So what you need to do is draw theta in quadrant 1. Now this is going to be strange, but it ain't no big deal. Here's theta. By the way, where does my, this is x over what? X over what? What's the number? 1. I have no time for this. So this is x. This is 1. We can express this side in terms of x through the Pythagorean theorem. 1 squared minus x squared, but what do I have to do to that? Square root it. That's all we got to do. Oh gosh, nothing. It's no big deal. Because now you know what you can do? What's the cosine of theta? 1 minus x squared, the square root of it, divided by 1. So 2x equals sine of pi over 2. By the way, what's sine of pi over 2? 1. What's the cosine of theta? Root 1 minus x squared minus, find 0 times, what's the sine? X. And then solve that equation. By golly, how am I going to do that? Oh, I'm sorry. No time. Square both sides. That almost looks like a dead skunk. 4x squared, and then this is just freedom. Okay, then what do we do next? Add x squared to both sides. Divide by 5. A root both sides. And where do we say x is located? Quadrant 1. So select the positive out of the plus minus. And by golly, I did square root both sides. So what goes in front of this? Plus minus. But because it's in quadrant 1, we select the positive. And it's all done.